The advent of low-cost computers on integrated circuits has transformed modern society. General-purpose microprocessors are used in personal computers, embedded digital control over objects, ranging from appliances to automobiles to cellular phones, and industrial process control. The development of microprocessor was a result of various breakthroughs in the semiconductor industry, like the transistor, SRAMs, DRAMs, and EPROMs. An interesting but true observation was made by Gordon Moore, the co-founder of the Intel, that over the history of the computing hardware, the number of transistors in a dense integrated circuit doubles approximately every 2 years. However, as the fabrication techniques have pushed devices' dimensions to their limits, Moore's law today seems to be hitting the wall. The Intel 404 is widely regarded as the first general-purpose programmable processor, was produced on 2-inch wafer and held to 2300 transistors with a circuit line width of 10 microns. The Intel 4004 had program memory size of 4 kilobytes. All conditional instructions work within currently selected ROM. It has 16 4-bit input ports and 16 4-bit output ports. 4004 instruction set consists of 46 instructions, while the instruction length can be of 1 or 2 bytes. The 8008 was the first 8-bit microprocessor and laid the foundation for future microprocessors. From Intel, it was a 8-bit CPU with an external 14-bit address bus that could address 16 kilobytes of memory. The Intel 8080 was the second 8-bit microprocessor designed and manufactured by Intel and used the same basic instruction set and register model as the 8008, adding a few 16-bit operations to its instruction set. But it was neither source code compatible nor binary compatible with its predecessor. Other well-known 8-bit microprocessors that emerged during these years were Motorola 6800 1974, General Instrument PIC 16X 1975, MOS Technologies 6502 1975, Xerox Z80 1976, and Motorola 6809 1978. The next phase of microprocessor evolution was brought about by the introduction of RISC machines. The typical RISC CPU had a 5-stage pipeline wherein all the instruction and data were in cache, and all instruction took only one clock to execute. The pipeline remained full and proceeded without tailing. Decoding was also simplified compared to the CISC CPUs by having fewer opcodes and eliminating complex instructions. The Intel 8085 is a conventional one new human design based on the Intel 8080. Unlike the 8080, it does not multiplex state signals on the data bus, but the 8-bit data bus was instead multiplexed with the lower part of the 16-bit address bus to limit the number of pins to 40. The 8086 is a 16-bit microprocessor chip released in 1979, was a slightly modified chip with an external 8-bit data bus. The Intel 8080 microprocessor is a variant of the Intel 8086. Introduced on 1st July 1979, the 8088 had a 8-bit external data bus instead of 16-bit bus of the 8086. Intel 80186 included features such as clock generator, interrupt controller, timers, wait state generator, DMA channels, and external chip select lines, had a 16-bit external bus multiplexed with the 20-bit address bus. The Intel 80286 was introduced on February 1, 1982. It was the first 8086-based CPU with separate non-multiplexed address and data buses, and also the first with the memory management and wide protection abilities. The 80386 was Intel's first 32-bit chip. The 386 had 275,000 transistors and over 100 times that of 4004. Versions of the 386 eventually reached 40 MHz. Here, we have attempted to demonstrate the various techniques used in microprocessor to handle instruction in an increasingly better and efficient manner. The techniques like sequential processing, pipeline processing, in-order pipeline processing, out-of-order execution, and superscalar processing have evolved over time and had led to faster CPU speeds. The microprocessor industry witnessed rapid development in 1990s, starting from the Intel Pentium processor, which introduced superscalar processing. After the Pentium 2, Pentium 2 and Pentium 3 introduced by Intel were huge hits. AMD entered the competition with its Athlon chip, which could match Intel in processing power. Early in the next decade, AMD introduced the Opteron, which was the first 64-bit x86 chip, which turned out to be quite popular. Intel introduced its Atom line of processor, while ARM concentrated completely on low-power devices. They were steadily captured the smartphone market by the end of the decade. ARM processors had a RISC-based computer design approach. Hence, they require significantly fewer transistors than typical 6x86 processor in most personal computers. This approach reduces cost, heat, and power use. Such reductions are desirable traits for the light, portable, battery-powered devices, including smartphones, laptops, tablets, and notepad computers, and other embedded systems. The latest processor by Qualcomm, the Snapdragon 805, based on ARM architecture, operates at an astonishing 2.7 GHz per core and has 4 cores. This performance outruns most of the Intel processors today, while operating at a significantly low power and cost. Further development of microprocessor in the same exponential manner, as witnessed in the previous decades, seems improbable unless a path-breaking technology is introduced and incorporated. Engineers face many problems in this regard, some of which are outlined here. Thank you.